Don't look in that corner. Recording, we're doing it. Hello and welcome to whatever it is that this is. I'm David and I've got a bookshelf that I'm using the wrong way. Today we're going to be building a cave ambience system. This is a system that will find a volume or a space and project upwards, firing sort of raycasts or line traces, depending on what engine you're from, off into the ceiling. And then from the ceiling we'll sort of drop these water droplets that are very loud water droplets, like Nerf footballs, I suppose, of water droplets, falling down towards the ground. When they hit the ground, they're going to play another sound, and this will be able to be scaled to any number of different areas. Now, if you've checked out the poolable systems in this video, that will be used heavily. So I'll put some of the scripts up on the website so that you can pick them up. We'll be doing this in Unreal Engine. It will be a C++ version today. Know that you can do this in Blueprint, and in fact, you should probably do your own transition across. Otherwise, if you want me to cover the Blueprint version, let me know. Jumping straight in to the script itself that will drive an actor component that will be the system itself. So you'll see this public actor script here. Now I've just called this, the project is called ejection particles. So if you haven't got it called ejection particles, that's okay. You're allowed to rename things, believe it or not. But essentially I'll have a header and a source file here, and I will pretty much be grabbing a few elements out of that previous talk. So things like this Metasounds element, the pool size, and the spawn audio source, but we'll run through it again today just in case. The components we'll be looking for that will be in addition is this little struct here. Now, this struct is trying to do something where we don't want to use physics. Ideally, we want to actually avoid collisions, and we're going to avoid collisions by doing a line trace and then calculating the time it would take for a droplet to fall. This looks like this. Now you can see over here, the version that I'm playing with has projected line traces, and they project everywhere upwards of the z-axis of the current actor. Now, the benefit for this is that we will be able to always hit the roof, essentially. If we don't hit the roof, or if we hit an area that is sort of so far away that the water droplet wouldn't be heard, or if the water droplet needs to fall too short a distance, I've also added some trims for that. Back in the script itself, we'll be looking at these components. Now, I have an array of sounds. They don't have to be Metasounds. They just are in my instance. And I have an array of impact sounds. Now, you could fire a trigger into a Metasound and do this in one instance, but I'm leaving this a little bit open to if you decide to do materials texturing or material triggering later on for something that might be able to detect and play the right sort of water droplet sound on a cave versus a mushroom, which should obviously sound pretty different. Now I have this drop component to ground and play, which just takes the start location and the audio component pointer that we'll be selecting a little bit later, and we'll go through what that does in a second. We have a spawn time, and we have a debug draw lines. I like doing these little debug draw flags. Sometimes it's really frustrating when you drop in a component someone has made and all the debug visualization is on all the time. We don't really want that. Now we have two trace distances which we care about. We have a roof trace distance. This is the distance from the actor component itself up to the roof, or at least in a cave. The reason I picked a cave here is not just because it's this beautiful asset pack from the asset store, but because it has heights of many different levels in the roof. So the benefit of that is that it won't just work in box rooms with perfectly manicured interiors. It'll also work in really yucky, well, not yucky, it's a beautiful cave, don't get me wrong. The max ground trace distance, and this is a little bit different from the roof trace. The roof trace is from the actor, the cave system that we're building now, up to the roof, and then the ground trace distance is from the roof down. It will need to fire a different amount because we're probably happier with a droplet falling further than it is to be spawned further up. The difference here as well is that I wanted to make a system that would be able to be scaled by different distances and different volumes as well. Because once we get in Unreal, there's literally just one reverb volume, and that's all we've done. The other thing is, while we could trace up and not hit something, let's say the ceiling is so far ahead or so high up that we do the whole max roof trace distance without firing or without collecting it, We don't want to spawn something there because I sort of think of these as like stalactites. As a stalactite forms from the roof of a cave, and if it's stalagmites, I'm going to lose it. But a stalactite looms from the top of the cave, falls down, and sort of water droplets and things like that collect on that and fall down, as opposed to just things falling from the roof. I actually wanted a physically accurate system. Then I had a minimum falling distance. This minimum falling distance is for the component itself to be able to make sure that we don't detect, the underside. Like, so if we had like one mushroom here and one mushroom here, we don't want to detect this spot and have it fall like the tiniest distance. We'd just be wasting the opportunity for the player to hit it. You can, of course, tweak these so that if you found that you were getting too many droplets and you wanted to make the criteria a little bit smaller, have harder conditions to be able to play these things, you could do that. Finally, I have this fall speed modifier. The fall speed modifier is there to be able to do projectiles or droplets of different speeds if you wanted to, or you could have them fall slower. So if you had a more sort of, initially I went with this like fairy cave idea where I was going to have like musical, beautiful things, because I keep using the glockenspiel from this video, but I chose not to do that in the end. So the fall distance or the fall speed modifier doesn't really change. The timer handle will be the thing that re-triggers our script, and the pool of audio components is so that we don't continuously make and destroy audio components. We just make them once at runtime, and then we can kind of reuse them whenever we want. Finally, we have this get available Metasound component, and this will be able to grab an unplaying source. We have one more component which I didn't talk about a little bit earlier, which is this process pending sound drops and the pending drops themselves. But rather than go into those, I'm going to jump into the script and we'll get back to it. First up, on play, we're going to create the components. We're going to create, these are all audio components that will have transforms that we can move around and play at different areas, and it's a scalable pool size. So if you choose to have 10 sounds, if you choose to have 1 sound, 5 sounds, 200 sounds, don't do 200 sounds because your programmers will kill you, but if you want to get killed by a programmer, it's very efficient. So finally, we want to set up the timer handles to run this spawn audio source by the time. So if we choose to scale that time as well, like maybe by distance, like if we get into an area, we can up the distance, and then as we're outside or whatever, we can do something differently. In the tick function, we're just going to be processing the pending sound drops. This is like a little packet of sound drops which will have information like what sound to play or what sound they're currently playing, when they started falling, where they're falling from, where they're falling to, and when they're going to finish their fall, so that we can avoid the physics calculation here. I think this is a pretty cool way to do this. You could definitely do this with physics if you wanted it to bounce around as well, but I didn't. So, Next up, we have this spawn audio source. Now, if there are sounds to be spawned, we go and pick a random sound that we'd like to start playing. If we pick one that is valid, then we go through and we get a component for it. If the component does not return null pointer, because if I go to this function itself, we can see the component basically just checks that there is an available pool, and it otherwise returns null pointer. So if it can't be found, we don't go any further. We were sort of maxed out, I suppose, and we can't play anymore. If we can play one, then we set up the sound on it, and we get the actor location for our current spot. This is where the blueprint brain, I suppose, or where the cave audio system brain starts. And we're going to fire this random direction, which is a random normal 2D space. And then we're going to scale up the Z direction so that we can hit somewhere above us, basically, in the Z direction, because we don't want to be firing rays downwards, because if they fire them downwards, they're already falling and they're sort of below. This is just a design constraint I put on myself. You can, of course, fire this in any way. And the same system can be kind of modified to do like a grenade debris particulate kind of thing shooting off as well, which I might do in a further video. If you'd like to see that, you need to subscribe and say hello and, say, I would like to see the thing, and the thing might appear. Next up, we normalize the distance and we get the end location, which is the start location, that start point, plus the random direction that we've chosen, plus the max roof trace distance. So this is so that we can fire off a trace, and if it happens to collect with something, which we store in the hit result, then we check, did we hit anything? And if we did, we need to move on. Next up, we'll be drawing some debug lines. These are literally just for debug visualization because I think it's important to see what it looks like as we're going. They look like this, which I'll put in. Next up, if we get a valid roof location, this is if we fired from our brain, from our cave audio system actor component, and we fired off into a random roof space somewhere in the positive Z dimension, then we will say we hit something or we don't hit something based on this line trace by channel. And inside that, we will set up the hit result location. This is to pick the point at which the stalactite might form. Now, we aren't actually making the geometry of the stalactites. Remember, we're just inferring the geometry of the stalactites. Next up, we'd like to set the world location of the component, which is the one that we pulled from the available pooled sources, and we'll put that on the roof so that it can start playing sound. Now, if you're not going to do something that's playing sound in the air, you can of course skip this point, but be pretty weird for me to not do it in the video that I said I would. Next up, we can drop a component to the ground and play. This is a different function that we'll be setting up soon, where we'll be passing in this new location, which is that hit result from us to the roof, that roof position right there. Next up, we could, of course, if we didn't get a roof result, play something, but then it would be falling from like middle air stuff. Let's have a quick squiz. Oh, finally we run it again afterwards. We're just restarting the timer each time so it re-triggers. Next up, we'll look at pointing from the roof to the floor and whether or not that's valid. So we'll be looking to start location and then go a new vector of 0, 0 max ground trace distance. This is the Z dimension going 1,000, 2,000, 10,000, however far you want to go down to work out, hey, we do the same thing. Do we hit something? If we do hit something, and again, we have some debug stuff here just to say like whether it was a valid fall position or not based on whether we hit something far enough or not too far enough, I should say, from us to the max ground trace distance, knowing that, remember, we're on the roof looking down at this point. If we do, we want to check that point is valid, that we do have something. And if we have got something, then we're going to set up the distance to fall. This is taking the location minus the start location, which is going to be our start locations being on the roof, hit result locations being on the bottom, and the size of that is going to be the magnitude of those two vectors and being the distance to fall from there. If we have a valid roof position and we have triggered the bottom, the floor, and we do have that valid as well, then we'll want to set up a check to say, is it too small? Now, you can imagine here if we had two components, like if a person's standing and they fire off at the roof and then there's a tiny point that juts out, we probably don't want to trigger that point, hence me just sort of dodging that altogether. Finally, we get to the point where the thing actually happens. Now here I have some components here where I'm setting up this F sound drop info. Now this is a struct, and I did say I was going to come back to this. Well, let's have a quick look at the struct. The struct itself is super duper small, so it should be nice as a way to understand what's going on. Now we have this Metasound component, which is, it's called Metasound comp, but it's actually just an audio component. The audio component will be a pointer to the one that will play a sound, and that will get filled in by the system. So this is essentially a speaker itself, or maybe it's a cable towards a speaker, I suppose, and then we're going to plug it in from the brain a little bit later on. We're going to have a start and end location just so we can keep track of the droplet falling, because remember, we're doing this without physics, so it's a little bit more optimized. And then we're going to have a start time, which will be a CPU time itself. It won't be a time from the game. It'll be the time that we feed in that way. And a duration. This will be the time it takes for the droplet to fall from the top of the roof to wherever it hits on the floor, and that's the entire struct. Now this struct itself, we actually do have an array of them. I call them pending drops because we kind of construct this struct and we fill it with some information about a drop, and then we play it or don't play it or change it out. So back in our source file, if we do find that we have triggered from our actor component to the roof, that's valid. From the roof to the floor, that's valid. From the roof to the floor's length is more than the minimum amount that it should be falling, then we're good to go. We can start setting this up. So we're going to make a new struct on the heap. We're going to be setting up that Metasound comp, which is that audio component pointer that's there with the audio component that we passed into this function, this one here, from our spawn audio source, which is this one here, which is the new Metasound that we pulled out of that stack a little bit earlier. Finally, we're going to set the start location, the end location to be the hit result, and the start time to be the time in seconds at the moment, and then the duration of the fall, that's what this variable is itself, the sort of lifespan of the drop that's coming down, will be the distance it has to fall divided by how fast it's going, or how fast it's going to be able to do, because that's going to be in seconds. Finally, we're going to add that to the array and start playing the sound, which will be the falling sound that is being triggered there. If we did not, if our distance to fall was not larger than the minimum amount, so we do have a valid spot from the top, we do have a valid spot to the ground, but it's too short, you know, there's a piece right underneath it and it would sound bad or it would be pointless. I just write a quick little debug for a blue line instead of a red line so that it's slightly different. Finally, the last piece of the puzzle here, besides this available sound components, which we covered in that previous video, would be this process pending sound drops, which is the thing that runs on tick. So on tick, we kind of go through each of the pending drops, which is this index iterator here. We go through each of those and we grab the address of each drop. We check the elapsed time. This is the start time of the drop and the world time. So the world time minus the start time gives us the elapsed time. This is how long the droplet's been falling for. And if it's been falling for too long, we know that it has fallen, given that it's still maybe timescale stuff. So like there's a new Doctor Who and stuff, but don't get too excited with timescale in real time, please, because the whole thing breaks. So finally, we're going to go through and check, hey, if this thing has been long enough for this world and it's dropped long enough, we're going to set the location to the end location. And we're going to set the index to one of the random impact sounds that we have. We're going to set up the selected Metasound with the impact sound. So this is taking the wave out of the array, putting it in the impact sounds or the Metasound or whatever you want to do with it, setting that up and playing the sound and then removing it so that it can be reused, removing the index. And otherwise, if it hasn't fallen long enough, and we're just talking about one drop here, we're going to iterate over all the drops a little bit later. But if we're talking about that one drop, if we haven't, we're going to set up a new location, which is going to be lerping between the start location and the end location and just kind of picking the time slice, I suppose, that is moving between. Finally, we're going to set that new location for the drop. So the drop will look like it's falling, even though it's actually has no physics components and isn't falling in itself. Right, so you'll sort of see them falling. Right. So these are those little whistles. I have a pretty little cave to work with. Obviously, I didn't make this cave. It's one of the marketplace assets for this week, or this month, I should say. And you'll see it sort of takes its time falling. Get these beautiful little ground impacts. And the player gets this awesome spatialization that has these really, really interesting points right around them that we can kind of work with. The cave system itself, what's going on here? We're raycasting around, like I said. Whenever we hit green elements, we look for ground components. Whenever we find ground components, we check that they can be fallen onto like this, and then they fall. So this component itself has a fall speed modifier that we could kind of make them fall faster if we wanted to. I I think I'll probably have to restart if I do that. Yeah, I think it's one of those, like if I want to make it faster and fall, less, but make it poolable, 10 poolable sources, then I'll get a lot more droplets happening. Although I'm still only finding them 0.2 milliseconds apart. So let's go 0.6 milliseconds apart. Let's go 0.2 instead. Right, so it's going to find more valid spots to begin with, and it's going to drop a lot more objects. Now, who knows why people are whistling this much? But you could see this working with any positional sound source and in any environment, as you see, as long as you're happy with it just dropping down and not having like additional little sprinkles and things like that. So this is the crux of the system that we wanted to build today. Thank you for checking in. It is very much derived of the same stuff that I did with the Bazaar class, where I was spawning them at random areas, but moving them around a little bit and giving them a bit of drift. This is something that is very, very scalable, works in games, and is quite cheap if you think about the Raycasts only really firing each time they go. You could maybe make it slightly cheaper by checking the whole path of the sound before you even move the transform component itself. But that's the only part that I could see straight away. If you have more ideas of how you might use these things, for instance, I really want to see someone do the grenade particulate kind of debris thing going on, and I'll see you next time.